Hello and welcome back. For this video, we're going to be discussing how to convert decimals to fractions, and that will also include repeating decimals. The first one is pretty easy, and I chose 0.25 because a lot of you know what that is going to be as a fraction. We know it's supposed to be 1/4. And what you've been taught in the past is to count out your place values, so that'd be tenths, hundredths, or 2500ths. There is a little bit of a shortcut to this. All you got to do is draw a fraction bar and put a 1 on the bottom. Then you take whatever you have on the decimal side, in this case it's a 25, and you put it in the numerator. And then you go back and count how many decimal places do you have. Well, we've got 2 of them. So for each decimal place that we have, we will add a 0 to the denominator, and that's our fraction, 2500ths. The only thing you need to do now is simplify. And of course we would divide by 25 here, divide by 25 here, and the output would be 1/4, 1/4. We'll do that again, only we'll have a whole number part of it right here. So the first thing you'll do is draw your fraction bar, put a 1 under it. But now you're going to put this whole number 4 out in front of the fraction because that is the whole part of your mixed number you're about to create. We're still going to take the number here and put the numerator, but I'm only going to put a 5 because I don't need the leading 0. It does not change the number. However, when I go to count how many zeros I need, there's actually 2 decimal places in the problem. Therefore, I still need 2 zeros in my denominator. So that's pretty much the fraction. All you got to do is simplify. So we're going to divide by 5 here and divide by 5 here, and we'll end up with 1/20. So 4.05 is the equivalent of 4 1/20. For this example, we have a repeating 0.4. Now right now the entire thing is repeating, and that's the easiest way to convert to fractions. Instead of putting them over 1, we're going to take that 4 and put it over 9. And if that's possible to be reduced, we'll go ahead and reduce that, but 4/9 does not. And if you want to take your calculator and do 4 divided by 9, you'll see that it does give you a 0.4 repeating. Well, what if we have a 0.45 repeating? Well, first thing we do is put our fraction and put our whole number out in front of it. We are going to have the 45 in the top, but instead of adding zeros for each number that repeats, we're going to add a 9, so I have 2 of them on there, and 3 45 99ths is the equivalency. And if you divide the 45 divided by 99, you'll see you'll get a 0.4545. However, this can be reduced, so I'm going to go ahead and divide this one by 9, divide this one by 9, and that will give me 3, and 45 over 9 is going to give me 5, and 99 over 9 is going to give me 11. So it's the equivalent of 3 5/11ths would give me 3.454545. In this example, this is where the conversion of repeating decimals to fractions becomes a little difficult, and you're going to have to use some algebra to solve it. You'll notice that only the 4 and the 7 are actually repeating, not the 2. So we got to be careful. We have to adjust our numbers a little bit. So the first thing we're going to do is we're going to assign that a value of n. And then we're going to come over here and write the number 10 and put a little exponent box there, because what we're going to put in that box depends on how many numbers we have repeating. Well, if we look at how many numbers we have repeating, we can see we have 2 of them repeating. So we're going to put a 2 here, and that's going to equal 100. So what we're going to do is take this equation, n equals 0.247 repeating, and we're going to times it by 100 on both sides. So we're going to have 100n on this side, because I remember I'm just timesing by 100. And on the other side, times by 100 moves the decimal over 2 places to the right, so I end up with 24.7. But you'll notice that I don't have a repeating after that 7, so what I got to do is add the next 2 digits that continue the repeating pattern. So I got to go past that digit, that 7, until I see the repeating pattern again of 47. And then here's what we do. We're going to go back to our original n equals. That's 1n, and we're going to subtract 1n from this side, and that will give us 99n. And on the other side, we're going to subtract what 1n is equal to, which is 0.247, and the 47 is repeating. Now when you do this right, you remember back to elementary, you got to have your decimal values lined up. When you do this right, you'll see that the 47s are lined up infinitely, and when you subtract them, they will cancel each other out infinitely. All you got to do now is take what's left over, bring your equal sign down, 24.7, and subtract the 0.2 from it, and you'll end up with 24.5. 0.5. Get n by itself, so we're going to divide both sides by 99, and we're not actually going to divide it out, we're going to leave it in fraction form, so this would be n equals 24.5 over 99. And the only problem with this expression is you're not allowed to have decimals inside of fractions, so we can fix that real easy. I got to move that decimal over one place, so I'm just going to times it by 10 over 10, and that will give me 245 over 990. Now technically that's it. If you take 245 and you divide it by 990, you will get a 0.2474747. However, this number should be reduced. They're both divisible by 5, so we can go ahead and divide by 5, and that will give us 49 over this 198. This will be our final simplified answer, 49 over 198. Okay, we're going to do this again, only we're going to have a leading number, a whole number that has a 7. So we're going to take just the decimal portion here, because that's the only part we have to worry about converting to a fraction. So we're going to drop the 7 off. We're going to kind of put the 7 over here for a second, call that a 0, and then rewrite that as n equals 0.05 with a repeating 5. Because when we create our fractions, all we got to do is take that 7 and put it out in front. We don't need that 7 when we're trying to convert our repeating decimal into a fraction. N is equal to 0.05. So what we'll do first is put a 10 in an exponent box, and you can see that we have only one number being repeated, so it's 10 to the first power, which equals 10. So I'm going to multiply this by 10. So I get 10n is equal to I can put a 0 there, 0.5. And I'm going to add another 5 repeating. The reason being here is I have two decimal places that need to line up. Okay, now we're going to subtract one of those n's, and one n is equal to 0.05 repeating. And when we do that right, we'll have our repeating decimals lined up. So this cancels out, leaving 0.5 minus 0. So that would be 0.5, and I still have a 10 minus 1 over this side, which is 9n. Divide both sides by 9, so n equals 0.5 over 9. But we can't have a decimal inside of our fraction. So what we're going to do is move that decimal over one place, so all we're really doing is timesing by 10 over 10, and that's going to give us 5 over 90. And yes, you should reduce that, so we're going to divide by 5, and we'll get 1 over 18. And don't forget, we had a whole number. So we're going to take that 1/18 and just attach the 7 to the front of it. So it becomes 7 and 1/18.